Hello everybody and welcome to lesson 9 probability sampling. In this lesson we will cover the following 3 topics, that is when to use probability sampling, types of probability sampling, merits and demerits of each type of probability sampling. As we discussed previously, there are 2 types of sampling, that is probability sampling and non-probability sampling. In this lesson we are trying to cover the probability sampling. In probability sampling, each member of the population has a known, non-zero, and equal chance of being selected from the target population. If we take a target population of 150, so the probability of being selected from the target population of each member has 1 over 150. Probability sampling is typically used in quantitative research. It is not used in qualitative research. You can refer back, you can refer in the previous lessons about the types of research. Probability sampling allows to make statistical inference about the population or the target population by minimizing the selection bias. Selection bias can be minimized by the randomization principle, or providing equal chance for each member can minimize the selection bias, and this makes to have statistical inference about the target population. And the finding of the sampling can be generalized to the target population with a specified level of confidence. Since there is statistical inference, so the finding that is obtained from the sampling can be generalized to the target population with a specific level of confidence. By the way, the level of confidence can be 100 if we conduct census. If not, if we conduct sampling, so our level of confidence is obviously less than 100. Probability sampling is usually involves taking large samples that is considered to be a representative of the target population. So in probability sampling, we require larger samples that can be a representative of the target population. Continuing to the conditions for conducting probability sampling, or the following are the scenario or the circumstance, or we can say the requirements to use probability sampling. So the first requirement to use probability sampling is clearly defined target population or sampling frame. The sampling frame or the target population should be clearly defined or clearly known or should be identified. If we have a defined target population or identified target population or sampling frame, so we can proceed, we can use probability sampling. And the next parameters that have to be fulfilled is the random selection. To use probability sampling, we can apply random selection. If we cannot apply random selection for selecting the samples, so it is not possible to use probability sampling. And the other is independence. By independence, we mean that the selection of the first sampling unit does not affect the probability of the second, the third, and so on. That means if we take a target population of 100, so and if we select one item, the first item, so the probability is 1 over 100. And if again we select the second, the third, and the fourth, and so on, so the probability should be 1 over 100. That is the same. So this is what we call independence. And the other is adequate sample size. We have to get adequate sample size for representing the target population. Actually, the sample size is determined by the level of precision. For example, if we require higher level of precision, higher level of correctness, so the sample size will be higher. If we require lower level of precision, so the sample size may be smaller. And the other factor that determines the sample size is the variability of the population. If there is high variability in the population, or if the population is heterogeneous, we require larger sample size. And the reverse is also true. If the homogeneous population exists, so we require smaller sample size. And the other is the intended statistical tests. Some statistical tests require larger sample size, whereas the other statistical tests require smaller sample sizes. And the last one is representativeness. That means the sample that is taken from the population should have the same characteristics of the target population that the sample is drawn from. So Let's keep in mind that these 5 criteria should be fulfilled to use probability sampling. If this criteria cannot be fulfilled, we cannot use probability sampling. Let's proceed to the merits and demerits of probability sampling. The main importance of probability sampling is it is a representative, the sample is a representative of the target population. So since there is a randomization, since we select the data based on the randomization principle, it minimizes the selection bias, and that makes us to have statistical inference. That means we can conclude about the population based on the sample taken from the target population. On the other side, there is a disadvantage to use probability sampling. So one of the main disadvantages of probability sampling is resource intensive, or in some cases it becomes inefficient. It means that if we require larger sample size, particularly we require large amount of resources to collect that large amount of samples. So this is the main disadvantage of probability sampling. Let's proceed to the probability sampling types or methods of probability sampling. There are 5 divisions of probability sampling: simple random, systematic, stratified, cluster, and multistage. Let's discuss one by one. To start from simple random sampling, in simple random sampling, by the way, it is a direct method of sampling. Simple random sampling is a direct method of sampling that assigns each element of the target population an equal probability of being selected. Here, there is equal probability of being selected. Each member has equal probability of being selected from the sampling frame. There are procedures, by the way. When we use simple random sampling, we have to follow the procedures. So the first step to use simple random sampling is sequentially assign a unique identification. We have to assign unique identification number to each element in the sampling frame. So this is the first step. We have to assign different or unique identification for all the elements found in the sampling frame. After assigning unique identification, the second step is we have to determine the sample size. Actually, we will discuss about how to determine the sample size in the next lessons. So after determining the sample size, we use random number generator. Random number can be generated either using XL or SPSS. So after generating a random numbers by using XL or SPSS, so based on the identified elements that is generated, so we just select the samples from the target population. And the last step is we have to ensure that no element is selected more than once. Every element should be selected. Every element should be selected either a probability of 0 or 1. So let's take one example, and we will apply these procedures or these sequences. For example, if this is a population or a sampling frame, so the first step is we have to assign identification number to each element. So let's assign 1, 2, 3, 4, 5 up to 15. So after assigning the identification number, so the second step is we have to determine what? The sample size. Let's assume that our sample size can be 5. So the third step is, after determining the sample size that is 5, the third step is we have to use XL or SPSS to generate random numbers. So our random numbers, let's assume that our random number generator provides us 3, 6, 8, 12, and 14. So now let's select the third item, that is the third item, this one, based on the sample, based on the random number generator. Let's select the third one, the sixth one, the 8, the 12th, and the 14th. So we select this. So these are our samples, and we have to ensure that no element is selected more than once. So our sample will be this one. So this is the procedure how to conduct the simple random sampling. Moving to the simple random sampling merits and demerits, the main merits is there is equal chance of being selected, so this reduces bias, and if we reduce the bias, we can just talk about the representativeness. Particularly, it provides a representativeness for the population that is homogeneous population. If it is heterogeneous, actually, if the population is heterogeneous, we cannot use the simple random sampling. Moving to the demerits, it requires a complete sampling frame, or it requires updated and complete sampling frame. This may be sometimes difficult to obtain. Sometimes the sampling frame may be outdated, or the sampling frame may use repeated data or may lack some samples. So it is very difficult to get a complete sampling frame. And the other is inefficient for larger population. In larger population, we most probably we require larger sample size. So in that cases, it becomes inefficient, or it requires large amount of resources to collect those large samples. When to use simple random sampling? Actually, there are situations to use probability sampling. We have discussed the situations or the criteria that have to be fulfilled to use probability sampling. In addition to that criteria, to use simple random sampling, the population should be large. If it is small, by the way, if the population is small, we can use census. No need to take samples. And the second criteria is homogeneous population. If it is heterogeneous population, that means if there is variability in the elements in the population, so we have to use stratified sampling. If the population is homogeneous, we can use simple random sampling. Here, don't forget that the criteria, these criteria are adding with that of the probability sampling criteria. The probability sampling criteria are the general criteria to use probability sampling, but these are the particular criteria to use simple random sampling. Proceeding to the systematic sampling, in systematic sampling, we follow the process of just randomly selecting an initial starting point. We select randomly the initial starting point on the list, and thereafter every nth element of sampling frame is selected. Anyway, let's see the procedures on how to use systematic sampling. The first procedure, the first step in using systematic sampling is determine the sample size. We have to determine the sample size using different techniques that will be discussed in the next lesson, and then calculate the sampling interval. The sampling interval is, by the way, the number of elements between each unit selected for the sample. It is the interval between each unit selected. So the sampling interval is calculated by dividing the population with that of the sample size. After getting the sampling interval, then we select the initial point. We have to select randomly the first element, then with that sampling interval, we have to select the next and the third and so on. Anyway, let's take one example to see how to proceed, how to conduct systematic sampling. Look, this is the population that is 11, or we can say the sampling frame. So if this is a sampling frame, now let's assume that the sample size which is adequate is 4. Let's assume that the sample size is 4. So the sampling interval is found by dividing the 11 or the population by the sample size that is 4. So 11 divided by 4 is approximately 3. So the sample interval is 3. Now let's select the first element. Let's assume that let's randomly select the first element, that is 2. So after the interval, after sample interval that is 3, after passing, let's count. If we start this one randomly, this one as initial starting point, now let's start 1, 2, 3. So the third one is selected for the second. Now let's again count 1, 2, 3. So the 8th one is selected, and start from this 9, 10, 11. So this one is the third. So we have to jump with the amount of sample interval. The sample interval is 3, so we jump. After selecting the first initial point, we jump 3 items, or we select the third item starting from the initial starting point. So our sample will be this one. Look, the second, the fifth, the 8th, and the 11th are our samples that is selected from the target population. Proceeding to the merits and demerits of systematic sampling, when we see the importance, it is relatively easy to implement and less time-consuming methods because it is just a modified versions of simple random sampling, so it is relatively easy to implement. And it provides a representative sample if the population is randomly ordered. If the population is randomly ordered, so it becomes a representative. On the contrary, there are disadvantages to use systematic sampling. It is vulnerable to periodicity if there is a repeating pattern. If there is a repeating pattern, for example, if the repeating pattern is with the third items, if we take the previous example, our sample interval is 3. So if there is a pattern of repeating with 3 intervals, with the interval of 3, so we may encounter a periodicity, or we may introduce bias if there is hidden pattern in the population list, because we are following the pattern that is just passing the 3 interval to choose the elements. When to use systematic sampling? Systematic sampling is applied when the following are satisfied. Here also don't forget the criteria to be fulfilled in probability sampling, the general criteria, but the particular criteria for systematic sampling is large and homogeneous population. Simple and efficient sampling method is desired. If we require simple and efficient sampling method, we can apply systematic sampling. And the third one is random starting point is possible. To select the starting point randomly is possible. So if these criteria is fulfilled, so we can use systematic sampling. Proceeding to the third types of probability sampling, that is stratified sampling. As the name indicates, here in this type of sampling, we group the sampling frame into relatively homogeneous subgroups. Actually, the assumption is stratified sampling is the population is heterogeneous. So we have to group, we have to form a strata based on the predetermined criteria. So the strata should be distinct and non-overlapping. Let's see the procedures to how to conduct stratified sampling. So the first step is we have to form strata or group. For example, we can take gender, we can take education level, or we can take the salary, or we can take other criteria that is predetermined criteria to form groups, to form distinct and non-overlapping groups. So based on that, we have to form a strata or group. And the second is we have to just select random selection from each group based on the proportion. Actually, here we can apply the previous methods or the previous techniques, either to use the simple random sampling or systematic sampling methods from each strata. We can use either simple random sampling or systematic random sampling from each strata. Let's assume that these are our target population. So let's have that these two groups are based on the gender. So this one is female, this one are female, and the remaining are male. So we have here two strata, two groups, which is divided based on the gender. So from these two strata, we can apply either simple random sampling or systematic sampling, because they are homogeneous population within a strata. They are relatively homogeneous, so we can apply either random sampling or systematic sampling. Coming to the merits and demerits, to start from the merits, it ensures that stratified sampling ensures all subgroups are adequately represented, so the subgroups cannot be missed in strata. And allows for comparison between each group. We can compare each groups. We can compare male from female, or we can compare high income with low income. We can compare different groups in stratified sampling. On the contrary, there are disadvantages. It requires accurate information on the population characteristics. To create appropriate strata, by the way, to create a strata, to create a group, we have to know the characteristics. We have to know the characteristics of the population, like gender, like economic levels, or maybe experience or academic levels. So we have to know such criteria to classify or to form a strata. And the other is resource intensive if there are many strata in the population. If there are many groups, or if there are many subgroups which are relatively homogeneous groups, so it requires large amount of resources just to take sample from each of those groups. When to use stratified sampling? We use stratified sampling if the population or the target population is heterogeneous, or a variability among the sampling unit exists, and divide into distinct subgroups. We have to divide this into distinct groups. And the other is if we require accurate representation of each stratum or each groups, we can apply stratified sampling. So in these cases, we have to apply stratified sampling. Continuing to cluster sampling, in cluster sampling, we require to divide the population into groups, into clusters or groups based on the different criteria like geographical location, organizational units, or other relevant criteria. Actually, this type of cluster sampling is used. It is used when it is difficult or impractical to sample individual units directly. Let's see the procedures to use cluster sampling. The first one is developing cluster. We have to form clusters with different criteria like geographical location or other organizational units or other criteria. We have to form clusters or groups. And after that, we have to take a random selection of clusters. We have to take, instead of taking a sampling unit, we have to consider the clusters as a sampling unit. So we have to select randomly the clusters. We have to randomly select the clusters from each grouping. And the third one is all sample units in the cluster, in the selected cluster, is sampled. All sample units in the selected cluster is taken to be as a sample. Let's assume that these are the populations. Look, if these are the populations, so let's randomly select. First of all, let's develop a cluster. So let's form 5 clusters. As you see here, the first cluster, the second, the third, the fourth, and the fifth. Now let's randomly select the 2 clusters, that is this one and this one. So all the sampling units included in these 2 clusters are included in our sample. So our sample will be 1, 2, 3, 4, 5, 6. All the sampling units found in the selected clusters. Moving to the merits and demerits, the main disadvantage of using cluster sampling is the main advantage of using cluster sampling is useful when it is difficult to construct a comprehensive sampling frame. If it is difficult to construct a comprehensive sampling frame just to select each sampling units, so we can apply cluster sampling. And the other is cheaper because sampling cluster than sampling unit is easier. So these are the importance. On the contrary, there are disadvantages of using cluster sampling because it requires accurate information of the characteristics of the clusters. To form a cluster, to develop a cluster, to develop a group, so we have to get accurate information parameters to divide or to form clusters. And the other disadvantage is the cluster members are more likely to be like than those in another cluster reduce representativeness. Sometimes the clusters within a clusters, the sampling unit may be homogeneous, but out of the clusters, the sampling unit found in one clusters may vary from the sampling unit found in the other clusters. So this may create an issue of representativeness. So this is the other disadvantage. When to use cluster sampling? The following criteria should be fulfilled to use cluster sampling. The first one is large and dispersed population. If we have large and dispersed target population, so we have to use cluster sampling, because in a dispersed population, we have to make clusters first. We have to divide the target population into different groups. And the second is more practical. Cluster sampling is more practical and cost effective to sample the entire clusters instead of using or taking individual elements. And the other is cluster represents the population diversity. The cluster need to represent the population diversity. The variety or the diversity within a cluster should reflect the population diversity. If that's the case, we can apply cluster sampling. And the other is sampling frame includes all the clusters and is available. If the sampling frame includes all the clusters and if it is available, we can use cluster sampling. Moving to the last type of probability sampling, that is multistage sampling. It is actually the extensions of cluster sampling, or it is the advanced versions of cluster sampling. Multistage sampling involves a sequence of stages, as the name implies. It is often used when the population is large and geographically dispersed. There are simple procedures to follow for multistage sampling. The first one is the population is divided into clusters, or we have to form a groups, and a random selection is conducted among that clusters. And the second is from the selected cluster, further random sampling is performed until the desired sample size is achieved. Let's take an example. Let's take one country. From that country, if we assume that if we want to take sample of college students to maybe to study about the college services in a country, so first let's select randomly the states from the country. If we select randomly, and if we select the state 2, state 3, and state 6, so among these there are cities. City 1 and city 4 is randomly selected from state 2, for example, and from state 3 maybe we select randomly city 2 and city 6, and from state 6 city 3 and city 4 are randomly selected. So among that city there are several colleges, so we have to randomly select the colleges from each city that is being selected. So maybe college 1 and college 2 are randomly selected from city 1 and city 4 respectively, and from city 2 college 1, from city 6 college 3, and from city 3 college 2, and from city 4 college 3 are selected. Then from these colleges, either we can just take a random sample, we can conduct sampling, or we can conduct census to know about the service quality of the colleges in a country. Moving to the merits and demerits. The merits of multistage sampling is it enables sampling in stages, with different stages, and it's more efficient for large population, for large and dispersed population, and it allows for stratification at different levels, and enhancing precision is the advantage of the multistage sampling. And the disadvantage is its complex design. By the way, the design is complex because there are stages, so complex design requires careful planning and coordination of multiple stages. And the other is potential loss of precision due to sampling error at each stage. If we make a mistake, or if we make an error, so there may be a potential loss of precision due to sampling error at each stage. When to use multistage sampling? Multistage sampling is used in the case when there is large and dispersed population. which can be divided into clusters or groups, and more practical and cost-effective to sample clusters. Then subsamples elements within selected clusters is possible. And the other scenario is sampling frame includes all the clusters and is easily available for the researcher. So if these criteria can be fulfilled, so multi-stage sampling can be applied. This is the end of our discussion. Thank you for listening. Have a good time.